So we left off on this slide where it says when multiplying or dividing by a negative on both sides, has to be on both sides, you must always flip the inequality symbol. So let's look at a few examples. For instance, if I were to solve for x in this inequality, since it's being multiplied by -9, I have to undo that with division by -9. Well, division by -9 tells me, hold up, wait a minute, I'm dividing on both sides by a negative number. I need to now flip my inequality symbol. So instead of the inequality symbol opening up towards the x, it needs to open up the other way. And 36 divided by -9 is -4. Down here, x is being multiplied times -1/5. So I can either divide by -1/5 on both sides, or multiply by -5. So I'm going to divide by -1/5 because those would cancel. Because I divided by a negative on both sides, I need to flip this inequality symbol so that it's facing the other way. And dividing by -1/5 is the same as multiplying by -5. So this is going to be a negative times a negative, so my answer will be positive 10. Same thing down here. You can either divide by -3/4 or multiply by the reciprocal. Like up here, I could have multiplied by -5 on both sides and I still would have gotten the same answer. So I showed you an example where you divided by the fraction. This time I'm going to show you an example where you multiply by the reciprocal. So I'm going to multiply by -4/3 on both sides in order for this to cancel. Because I'm multiplying by a negative on both sides, I need to flip my inequality symbol. Now this is like multiplying two fractions. Remember, when you multiply fractions, you multiply straight across. So -6 times -4 is a positive 24, and 1 times 3 is 3. I can simplify this further because 24 divided by 3 is 8. Okay, on the last one, now I have x on two sides of this inequality. So I need to move this x value over with this x value so that I can combine like terms. Because it's a minus, I'm going to add it. Drop down everything that survives. Adding doesn't flip the inequality symbol, so it's going to stay. Now that I have x's collected, I need to move my 13 over, so I'm going to add 13. And adding 13 again doesn't change my inequality symbol. And neither does dividing by a positive number. Divide by 11 and you get you get 20 over 11 is less than x. The other way you can write that is x is greater than 20 over 11. Look how the alligator's mouth is eating the x in both of these. Okay, so I had to flip my inequality for the first three, but I didn't have to for this last one. Okay, two inequalities joined by the word and or the word or are what we call a compound inequality. All right, so I have this inequality here. It says -4 is less than or equal to 5x minus 2 and 5x minus 2 is less than 7. So this is a compound inequality because it's joined by the word and. But how else can we write this? Something I notice is that 5x minus 2 is in both of these inequalities. It says that 5x minus 2 is greater than or equal to -4, but it also says that this 5x minus 2 is less than 7. So we can kind of sandwich it and smush it together and write an and compound inequality like this. Okay, so now I'm going to solve this like I would an equation, but notice that I have two inequalities. There's two sides to this. Okay, well technically there's 3 parts to it. So if I'm going to get x by itself, I need to get rid of the minus 2 and the times 5. So let's get rid of the minus 2 first by adding. Now, with these types of inequalities, we want to make sure that everything stays balanced. So it's not just adding 2 here and here, but it's also on this side. Okay, think of it as 3 parts. So that's what I want you to put in this little reminder, that you need to add or subtract to each part. Okay, so there's 3 parts and we added 3 times. So my 2's 0 out. I can drop down my inequalities, they don't flip. 7 plus 2 is 9. Drop down my 5x, and negative 4 plus 2 is negative 2. There's one more step I need to do to get x by itself, and it's to divide by 5. Remember, if I'm dividing one section of this by 5, I need to divide the other 2 by 5. So my 5's cancel. I didn't divide by a negative number, so my inequality symbols stay the same. I'm going to get fractions for my answers. And now that I've solved for x, I want to graph its solution on this number line. Okay, so this is a bounded interval because I have 2 endpoints, one at negative 2/5 and one at 9/5. Negative 2/5 is smaller, so it goes to the left. So remember, x is representing the solutions. This graph should be the solutions. What numbers can we plug in for x for this inequality to be true? Well, the numbers that we can plug in need to be greater than or equal to, so it can be equal to 2/5, but it's got to be greater than. But then the and part says it also has to be less than 9/5. Okay, so it can't be equal to 9/5, but it's got to be less than it. So any number in between negative 2/5 and 9/5, including negative 2/5, is a solution. The other way you can do it is a bracket and a parentheses to show included and excluded. Okay, so the solution set of an and inequality, this is important, consists of all real numbers that satisfy both inequalities. Okay, so the numbers that are greater than negative 2/5 and less than 9/5 are the solutions. They're in this interval or on this graph. It's got to fit for both. Then we have the or compound inequalities. So the or, we're going to treat or problems separately. Okay, so I'm going to solve them as like 2 different inequalities. So you can split it up and just focus on one at a time. So if I'm going to solve for x, I need to subtract 6 on both sides of this inequality. So that way they 0. Drop down my inequality symbol. 2 minus 6 is negative 4. And bring down my negative 3x. X is being multiplied by negative 3, so I'm going to divide by negative 3.
Well, patients, please report to the lobby. Please go to the lobby. Thank you.
Something I want you to notice is we did divide by a negative, so when that happens, we need to flip our inequality symbol so that it's facing the other direction now. Okay, so I've solved for x here, and I need to solve for x on this side. Again, I'm going to subtract 6. Subtracting 6 doesn't flip our inequality symbol, but dividing by a negative 3 will. Turn it the other direction. Okay, so it's either of these. Okay, so x is either greater than or equal to 4/3, or x can be less than or equal to negative 1/3. There's 2 types of solutions that will work. Okay, so let's look at what this would look like on the graph. I have my negative 1/3 on the left side and my 4/3 on the right side. So x is greater than or equal to 4/3. That means I have a closed circle at 4/3 and I'm talking about the numbers bigger, so the numbers off to the right. Or x can be less than or equal to negative 1/3. So I have this graph going on, which does represent my solutions. I can pick a number from over here and it'd satisfy this part, or I could pick a number over here and it'd satisfy this part of the inequality. But what I can't do is pick a number in here. It won't satisfy either of them. Okay, so a solution to an OR inequality just has to satisfy one of them. One thing I want you to notice is that OR problems the graph will always go out. Okay, so OR, see how the arrows go out? OR starts with O and out starts with O. That's a little helpful hint. ORs go out. Something I want you to notice about this AND problem. ANDs go in. So look how the N is in between A and D. Okay, so ANDs will go in between your two endpoints. ANDs go inwards, so the line is in the middle of the 2 points. ORs go outwards. Solve the compound inequalities and graph their solutions. So it's wanting two things. We first are going to solve. You can think of it as splitting it up into 3 parts on this inequality and getting x by itself in the middle. So I have a positive 4 here that I need to get rid of first. Okay. Eventually I want to get rid of the negative 7, but he's being multiplied. He's kind of stuck there. So we're going to subtract 4. And since I'm doing it in the middle, I have to do it on all 3 parts. Negative 10 minus 4 is negative 14. Drop down my inequality symbol. It hasn't flipped yet. Those zero out, and I'm left with negative 7x in the middle, and it's less than 6. One more thing I have to do here is divide by negative 7 on all 3 parts. Now remember, I'm dividing by a negative, so that's going to make my inequality symbol flip. A negative divided by a negative is positive. Flip the symbol so it's facing the other direction. My negative 7's cancel. Flip this symbol so it's facing the other direction, and I have a fractional answer. Okay, so it's saying that x needs to be less than or equal to 2, but greater than negative 6/7. So I'm going to plot that on my number line. It's an AND inequality, so ANDs will go in. It's got to satisfy both of these, okay? So let's plot my negative number on the left, my positive number on the right, and I want to make sure I get the right circle or bracket, whatever you prefer to use. Notice how with the negatives, it's not an or equal to, so that's going to be an open circle. And with the 2, it is an or equal to, so that's going to be a closed circle. I need numbers that are less than or equal to 2, but I also need those numbers to be greater than negative 6/7, so this and went in. Okay, or you can use parentheses and brackets and connect them. Now we have an OR. This OR problem, remember we treat separately. So if I'm going to solve for x, I need to subtract the 10. and then divide by 4. And we're dividing by a positive number, so that doesn't flip our inequality symbol. And I need to solve this one as well. But now I am dividing by a negative. So my rule is I need to flip the direction my inequality symbol is facing so that it's opening up the other direction. And it says x is greater than 9/2, positive 9/2. Okay, so this is an OR, so solutions are going to satisfy either one of these. So let's plot at -4 and 9/2. I don't need to get exact as long as I know which one's bigger and which one's smaller. I have an or equal to, so that's a closed circle at -4, and I have an open circle at 9/2 since it's not an or equal to. This one says x is less than or equal to -4, so the less than numbers are to the left. X is greater than 9/2, so those greater thans are numbers over here. So solutions can either be on this side or they can be on this side, and it would satisfy in the inequality. However, there are a few special cases, okay, that we need to be aware of when it comes to and or compound inequalities. You could probably guess that there are no solution and all solutions. So notice how there are infinitely many solutions here because it goes on towards infinity and negative infinity. Okay. There are also infinitely many solutions here. Like I could pick 1.97623, 1.97623, like there's all these different points on this number line. So a special case wouldn't be infinitely many solutions because technically these all have infinitely many solutions. A special case would be the entire number line or none of the number line at all. So let's look at those two cases. This is an and. Okay, remember an and's got to satisfy both. I can't shove this together because this says 8 minus 3x and this says x minus 5. So I can't form it to look like an inequality such as this one. I can't combine it together. So I'm going to have to treat these separately. That's fine. So a positive 8, I need to subtract 8 in order for those to cancel. Drop down my negative 3x. Subtracting 8 doesn't flip our inequality symbol, but this division by -3 is going to flip our symbol. So it's facing the other way. A negative divided by negative is a positive, 3/1. Okay, I'm going to drop down my and solve this one. To get x by itself, I need to add 5. And x is greater than or equal to 15. Okay, so I have x needs to be less than 1 and x needs to be greater than or equal to 15. So if you think about that on a number, like in terms of a number line, is there a number that is less than 1 but also has to be greater than 15? No, remember this is an and. It's got to satisfy both. So this is a no solution case because no number is ever going to be less than 1 and at the same time greater than 15. Okay, so the and, it's not going to work out. This would be fine if it said or, but it says and that makes a difference. Okay, let's check out this or problem. Remember, we treat OR separately. So we're trying to get x by itself. I'm going to add 3. Drop down my 0.4x. Drop down my inequality symbol, and 8.1 plus 3 is 11.1. I need to divide by the number with x, which is 0.4. That way they cancel. I don't need to flip my inequality symbol. And 11.1 divided by 0.4 is 27.75. Okay, so x is less than or equal to 27.75. Or let's figure out the other condition. Trying to get x by itself, so I can't mess with the negative 1.6 yet. I have to subtract the 4.2 before I can get the 1.6. Subtracting doesn't flip my symbol. 3 minus 4.2 is negative 1.2. I'm going to divide by the number x is being multiplied by, so divide by negative 1.6 or negative 1.6. Dividing by a negative number on both sides. Don't forget, you need to flip the inequality symbol. So instead of opening up towards the right, it's going to open up towards the left. A negative divided by a negative is a positive, and this would be 0.75. So think about this in terms of a number line. Here's 0.75 and here's 27.75. Is there a number that's less than 27.75 or greater than 0.75? Now notice how it's not an and, it's an or. It's not bounded by anything. Okay, so all the numbers that are less than 0.275 go this way. All the numbers that are greater than 0.75 go this way. And doesn't say it has to meet both those requirements. It just says it got to be either this less than this or bigger than this. Well, that covers the whole entire number line. Okay, if it's one or the other, if it's an or, and your graph looks like this, if you have an or that goes inwards towards each other, then it's going to be all real numbers for your solution. Okay, because every number that you pick is either greater than 0.75 or less than 27.75. Any number in the entire world is greater than 0.75 or less than. It's going to meet one of those conditions. All right, so those are your special cases that you need to be aware of. When ands go out, that's not natural, that's a no solution. When ors go in, that covers the entire number line, that's all real numbers. Okay, so we have a no solution, and then we have all real numbers. So be aware of that on WebAssign.